Hey, 8th grade. This is going to be the last video in the first half of our unit over quadratic functions. And so for this video, we're going to learn how to apply what we've been doing with graphing to some quadratic word problems. You're definitely going to want your graphing calculator for this because you are not going to want to solve these equations by hand. All we're going to be doing is similar to what we did with systems word problems. We're going to be setting up some equations for each of these problems, and then we're going to be using our graphing calculators and doing some of the analyze graph features on there in order to help us solve the problem. Some of these are going to look familiar from what we did last year, but it's always a good idea to refresh ourselves, and then some are going to look a little bit different, a little bit more complex, but all of them, as long as you have your graphing calculator and you know what part you're looking for, it's not going to be too complex in terms of the actual math. Okay, so let's look at number one here. This one should look familiar to you. For this one, we have an acorn falling from a tree, and that tree branch, should I say, and that branch is 20 feet above the ground. And so we're going to take this function right here, h equals negative 16 t squared plus 20, and that's going to tell us the height h of the acorn after t seconds. Okay, so we want to know about what time the acorn hits the ground. Okay, so we want to find t for this one, so it's always important to know what you're looking for because we want to know the time, and so that means we must be given h. Okay, so we're given that the acorn is hitting the ground, so that means h must be equal to 0. Okay, so we're going to find t whenever h is 0, and so we're going to go to our graphing calculator to do this. So we're going to take this function, h equals negative 16 t squared plus 20, and we're going to type it into our calculator. H in this case is my f of x, and so I'll do negative 16, and then we'll use an x instead of a t here, so x squared plus 20, and graph that, and here's our parabola. Okay, I'm going to just get rid of the equation here. So we want to know again when the acorn hits the ground. Well, if you're on the ground, that means your height is going to be 0, and so we were finding the zeros of this parabola here. Okay, well, remember from last year, parabolas are going to have either 2, 1, or no zeros. In this case, we have 2 zeros. Okay, those are, again, the x-intercepts of the graph, where the graph is crossing the x-axis. This graph here has 2 x-intercepts. It has one that is negative and one that is positive. We want to know the positive, okay, x-intercept, because we can't have negative time, so I am going to locate this x-intercept right here. And I'm going to do that using my menu, analyze graph number 6, and then 0 feature number 1. So it's always menu 6, 1 to find the zeros of a graph. And so this is going to be similar to finding the intersection point. You're going to have to click somewhere in between your 2 zeros, so maybe right here, and then drag your window over until you pass this 0 on the right, and that gives you the point 1.12 comma 0. You may get a longer decimal than that, but we're going to go ahead and round to the nearest hundredth place, and so if you round your decimal, you should get about 1.12. Okay, so it may help for you to sketch the graph on your paper just so you know what you're looking for when you look back at your notes. So again, this is what the graph looks like. And we want to find the 0, which is this point right here, and that 0 is at 1.120. Okay, so that tells us that t is equal to 1.12 approximately, and so we know that it's going to take about 1.12 seconds for this acorn to hit the ground. Okay, let's go on to number 2. This one is a 2-part problem. It says a water balloon is launched from a machine upward from a height of 10 feet with an initial velocity of 46 feet per second. And so that 10 and that 46 I've taken and put them in this equation for you. So this equation, h equals negative 16t squared plus 46t plus 10, will tell you the height of the balloon, h after t seconds. So similar to the last problem, except this time, I don't want to know when it hits the ground. I want to first of all know what is the maximum height of my balloon. So we're going to go back to our graphing calculator. I'm going to go ahead and clear out my last function. And now we'll type in this one. So we have negative 16 x squared plus 46x plus 10. And so I graph that, and I want to find the maximum height, meaning I want to find the vertex, so I'm going to need to zoom out a little bit in order to see my vertex. So So I'm going to go menu 4, 4, and zoom out. And notice when you zoom out on this, your graph is going to get a little bit thinner. That's because you're zooming out on the x values as well. This will work just fine the way I've got, the way I can see my graph right now. But if you want to maybe make it a little bit so it looks a little bit nicer parabola, you're welcome to do that. You can just trim this x-axis down here by manually adjusting your x values and not your y values. So if you go to your menu 4 and then 1, your Windows settings, you can shrink your x values. Like for instance, we don't need -38 as the minimum x value. I can make that -10, and then I can do the same thing with my x max, and that's just going to make the graph look a little bit nicer. Again, we're only concentrated on finding the vertex, so as long as you can see that vertex, you're okay. So to find the vertex, I'm going to go to Menu, Analyze Graph, and then in this case, the vertex is a maximum, and we're trying to find the maximum height, so I'm going to select 3. And so now I'm just going to go to the left of my vertex, click, and now go to the right, and that's going to put my vertex at 1.44, 43.1. Okay, so we want to find vertex, and the vertex is at 1.44, and then actually I think if your calculator is giving you more decimal places, it comes out to be 43.06 if we go to the nearest hundredth. Okay, so that means that the maximum height of this balloon is 43.06 feet. Okay, the second part is asking us to find when the balloon is above 30 feet. So I'm going to go back to my graph now. Okay, and again, I want to find when. So when you're finding when, you're finding time. Okay, so we want to find t when the balloon is above 30 feet. Well, to do that, I'm just going to draw a second graph on here. So I'm going to hit Tab. Now I get my F2 of x, and I'm just going to do the horizontal line y equals 30. So I'm just going to type in a 30 here. And all that's doing is that's showing me where my 30 feet mark is, okay? When does the balloon have a height of 30 feet? If it's below, so here's when my balloon's being launched. If it's below the red line, the balloon hasn't reached 30 feet yet. As soon as it touches that red line, it's at 30 feet, and from here on, it's above 30 feet, and then it reaches its maximum height, it starts falling down again, and then as soon as it crosses the red line, it's back below 30 feet. So what I'm asking in B is, I want to know for what period of time is it above 30 feet? So we want to know, okay, but what are your amount of seconds from this point here at 30 feet to this point here when it comes back to 30 feet and drops? And so to do that, I'm going to find 2 intersection points. I'm going to find this intersection point right here that tells me when it starts being at 30 feet, and then this intersection point right here when it ends being at 30 feet, when it crosses that threshold. So I'm going to use my menu 6, 4 feature, my intersection feature, and I'm going to find the intersection point, first of all, of this first leftmost intersection point between my red horizontal line and my parabola. So I'm going to make my window here, and I get the point 0.534, 30. So that's my first intersection point. And then my second intersection point, go to menu 6, 4 again. You'll want to click again in between your left and your right intersection point, so about right here. And then this one, we get the point 2.34, 30. Okay, so what that means is that this balloon is above 30 feet between 0.53 seconds and 2.34 seconds. Okay, that's the time period that is above 30 feet. Again, I recommend you draw a graph on your notes just so you have that to refer back to. So just make a quick sketch, okay? For part A, this is what our graph looked like. And we were trying to find the vertex, so we found this point up here, okay, which again was 1.44, 43.06. And then for part B, again, here's what your graph looked like. We drew a horizontal line, okay, y equals 30, and we found these 2 points right here. Okay, we found 0.534, 30, and 2.34, 30. Okay, moving on to number 3. On this one, we have a go-kart track, and this track has about 380 racers per week and charges each racer $35 to race. The owner of this track estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. And so this owner wants to know how she can maximize her weekly revenue. And basically what that's asking is how much does she need to reduce the price per racer in order to get a little bit more revenue but not to reduce it too much. Okay, so this is another maximization problem. Kind of like those linear programming problems we were doing with systems of equations. Okay, except for this one, instead of setting up a system of inequalities, we're going to do a quadratic equation. So again, what this is asking is how much do we need to reduce our price by to maximize the weekly revenue. So I'm going to write a let statement here because I'm not given an equation for this one, so we need some variables. I'm going to let x equal the amount of price reduction, because that's what we want to know. How much do we need to reduce the price by? The price right now is set at $35. Okay, so we want to know how much do we need to decrease that by to maximize our profit. So if x were 1, that means that the price would drop to $34. Okay, if x was equal to 5, that means the price would drop to $30. So x is the amount of the reduction. Okay, and then I'm going to also say that r of x, this is just function notation, is going to be my revenue. Okay, so r of x is going to tell us, okay, how much revenue are we actually going to make if we do this price reduction here. Okay, so let me break this down for you. Right now, it says we have about 380 racers per week, and we charge $35 per racer. So right now, our revenue is this. Our revenue is 380 times 35. And so 380 times 35 is equal to 13,300. Okay, so this is your current revenue right here. Okay, so we want to know how much can we reduce this price in order to increase this number so that our revenue increases as well. Okay, and that's what we're trying to find in this problem. And so what we're going to do is we're going to say, okay, our new revenue is going to be equal to this. Your new revenue is going to be equal to your original revenue, which is $35, subtract the price reduction. So we're subtracting whatever x is. Okay, so our new price per racer is going to be a little bit lower than 35. And we're going to take that new price per racer times the number of racers, which right now is $380. And right here is going to be the key. It's the estimates that there will be 20 more racers per week for every $1 reduction. So if we reduce the price by $1, that means this number 380 is going to go up by 20 times x. Okay, 20 times the number of dollars we reduce it by. So if we reduce this by $2, you're going to get 40 more racers. $3, 60 more racers. Okay, so now this is my new price right here, 35 minus x, and this is my new number of racers, 380 plus 2x. Okay, so now we're not going to actually multiply this out, even though you might remember how to do this from last year. Okay, that'll be coming up in the second half of this unit. We're just going to let our calculator do the work for us. So this is actually a quadratic equation, okay, even though you don't see an x squared. Remember, if you were to use FOIL, you would actually get an x squared if you multiplied this out. So I'm going to go to my calculator, go back to my graph screen, delete everything I've got on there, and we're going to type in this equation exactly as it looks. So this equation is the quantity, so make sure you use parentheses, 35 minus x, times the quantity, 380 plus 20x. Okay, and if we type that in, the way my menu is right now, my window is right now, I can't see anything, so I'm going to go to my window zoom feature, zoom out. I'm just going to keep doing that until I can see a vertex. Okay, and it looks like my y values are good enough now that I can see a vertex. Now, this doesn't really look like a parabola because I've zoomed out on x too much. So now I'm going to go back and go to my window menu again. I'm going to go to my window settings, and I'm just going to decrease those mins and those maxes to make it a little bit easier to see. So I'm going to make this negative 100, and this down here I'm going to decrease to 1000 and see what that does. Okay, and that just makes it a little bit easier to see. Now I can see my vertex is up here. That's what I'm trying to find. Okay, I'm trying to find my maximum. So now I can go to my menu, 6, 3, and I can go ahead and locate my maximum point, which is 8. And then you get this number, 1.46e plus 4. And if you remember, we've talked about this before, that's just your calculator's way of writing out scientific notation. So what that point right there really means is 1.46 times 10 to the 4th power, which would be 14,600. Okay, so this is what the point actually is, 8 comma 14,600, okay, which is again your vertex. Okay, so what that means is that 8 is our x value, so that's the amount we need to reduce the price by. So we're going to say that we reduce the price by $8, and what that's going to do is that's going to increase our revenue, okay, to a total of 14,600. So our revenue was 13,300, and now it's going to increase to 14,600 just because we're getting more people coming because we've reduced the price. Okay. So again, you want to go ahead and sketch that graph just so you can see how you found this when you refer back to your notes. Okay, here was your graph. Okay, and we found the vertex right there because we're looking for the maximum, and this is what we got for the vertex, the point 8 comma 14,600. Okay, we're going to do one more example. I'm going to skip example 4 in this video simply because I forgot to put the diagram in your notes. So don't worry about that example. We won't come back to it. It won't be, you won't have anything like that on your homework or your test. So you can go ahead and cross that one out and jump ahead to example 5 for me. Okay. So example 5 here says, a town has a butterfly conservatory with a rectangular field that measures 600 meters by 400 meters. And what the town wants to do is double the area of the field by increasing the current length and width by the same amount. So that's the key there. We're going to increase our length and width both by the same amount, and so we want to find the new dimensions of the field. Okay, so here's what we know so far. Let me go ahead and draw a diagram here. Okay, so let me go ahead and use a rectangle, that'd be better. Here's our current field, okay? So we know that the length of this current field is 600 meters, and the width of that field is 400 meters. And what we want to do is this. We want to increase the length of this field by some amount, and we want to increase the width by that same amount. So what I'm going to do is I'm going to say let x equal the amount of increase. Okay, so that's the amount I want to add to both the length and the width. So we're adding x here and x here, and what that's supposed to do is that's supposed to give us a new field that is this size, and the area of this field should now be doubled compared to our original field here. Okay, we should now have double the area. And so in order to set this up, I need to figure out what was my original area. Okay, so your original area would have been this. Okay, 600 times 400, length times width, which is 240,000. Okay, 600 times 400, you get 240,000. And so now, if we want to double that, we're just going to take 240,000 times 2, which gives me 480,000. Okay, so for my equation here, or my function, I'm going to write this. Okay, so the area we want now, okay, the double area, is going to be 480,000. and that's going to be equal to the new dimensions of our new field. Okay, so the dimensions of our old field were 600 and 400. The dimensions of our new field are going to be this: 600 plus x and 400 plus x. Okay, so I'm taking basically just my area formula for a rectangle. Okay, 480,000 is my new area, which again we want to be doubled from the old area. 600 plus x is my new length, and 400 plus x is my new width. Okay, so we're going to let our graphing calculator do this, but before I do that, I do need to make sure that this is set equal to 0. Okay, that's how I graph things on my calculator, is I need to make sure they're set equal to 0. So all I'm going to do here is I'm going to subtract 480,000 to the other side of my equation. You remember this a little bit from last year. This will be coming back a lot in our next unit, setting equations equal to 0. And so you get this. You get 0 equals 600 plus x times the quantity 400 plus x minus 480,000. Okay, so now I'm going to go to my calculator, delete my old graph here, and I'm going to type in that equation. 600 plus x, the quantity, times the quantity 400 plus x, and then we're subtracting again from that 480,000. Okay, again for this one, we're concerned with finding what x equals, or solving for x, so we need to be finding the 0, okay, of our function here, finding the 0. If you were to zoom out a little bit, you could see that this parabola, okay, is going to be doing this, okay, and again, we're not concerned with the vertex, so I don't need to zoom out anymore. I just need to find my positive 0, just like the first problem. My positive 0, which is going to be right here, okay, so I need to go to my menu, 6, and then 0 feature. Menu 6, 0, and find that point, which is the point 200 comma 0. So anytime you have an equation like this and you're solving for x, that means that you want to find your 0. And so we know our 0 here is 200 comma 0. So that means x is equal to 200. And so now let's make sure we answer the original question. The original question is saying to find the new dimensions of the field. Okay, so if we had 600 and 400 originally, now we need to add 200 to both of those. And so my new dimensions are this. If you add 200 to 600, you get 800. So we have 800 meters. And add 200 to 400, you get 600. So 600 meters. And just to double check, 800 times 600 does give you double the area, 480,000. Okay, feel free to go back through and watch anything in this video you need to, especially examples 3 and 4, because I know those are a little bit more complex than we did last year. So rewatch those, write down a question or two to ask me the next time you see me. And until I see you, have a nice day. You're all wonderful people. Take care.